Okay, so we're just going to wait until some people file in. Yep, I think it's safe to go ahead and start. Well, welcome, Bargava, to PyCon 2023.
Hey, thank you, Zara.
Happy to have you here. So in this session, we'll be exploring whether there could be a connection between radiology and Python. So radiology is a critical field in modern medicine, but it faces one major problem, and that is the growing demand for diagnostic imaging services. So this talk by Bargava Subramanian focuses on how Python and AI help scale radiology to meet the needs of a rapidly growing population. Bargava is a regular mentor to startups and teams in their data science journey as the co-founder and CEO of Crayon Incorporated. Please welcome Bargava as he takes over with his session, Scaling Radiology to Serve 1 billion people using Python and AI. Bargava, the floor is yours.
Thank you. Hello, everyone. Really excited to be here, talking about some of the very cool stuff that I'm working on with my team currently. Thanks, Zara, for setting the context. Very quick introduction about me. My background is machine learning AI. I've been doing this for close to 20 years. I specifically specialize in building data products. I currently am the Chief Product and Data Officer at India's largest AI-driven clinical delivery network, 5C Network. Let's start at a very high level with how a patient care happens. Patient goes to meet a specific doctor, so they have some complaint, they go to meet a doctor, the doctor examines the patient and then decide that the patient requires further diagnosis and so recommends diagnostic test. Common diagnostic tests are pathology, blood test, or radiology. The one that I specialize in at my company is in the field of radiology, which is all around imaging. So these are non-invasive imaging that is done on the patient to understand what's happening with the patient. The common things that we know are X-ray, it could be a CT scan, or it could be a MRI scan. The patient goes to either a hospital if it has the equipments there, or to another diagnostic center where they take the imaging. Typically, a technician is there who coordinates and takes the images. This gets sent to a radiologist. A radiologist is a specialized doctor who looks into these images and then, based on the history and other parameters of the particular patient, finds what the problems are in the images and then sends the report. And then the patient then goes to the physician for follow-up. Now, this is a typical setup, but like similar to what Zara started the talk with, we are rapidly growing, right? Like it's urbanizing, the lifespan is increasing. There's been a lot more demand for faster and accurate reports. Now, so as the number of people increase, the number of images that are taken increase, you also want most of them, I mean, no one simply goes into a machine just to have fun, right? They have some problem and it needs to be reported at a very specific, within a very specific time interval. And so turnaround time is extremely important. It's also important that it needs to be accurate, right? Because further diagnosis, for the treatment plans are entirely based on what the images tell and what the radiologist has reported. Now, in specific problems in emerging countries, specific, for example, I live in Bangalore, India, and then so India has this challenge, and so does Sri Lanka and many other emerging economies, where the number of qualified doctors are far less than the population that's around. And so you can't really have a lot of images backed up. It can't take like a week to get back to the patient. You need to be doing it in minutes, if not hours, and then get back to the particular physician to start the treatment. Which is where AI comes in, because it can play two dominant roles. It can automate a lot of stuff that are really easy for a particular doctor to do. It's just something that you can shrink the time. So if it takes like 30 minutes, a common example could be just measurements of what's happening in different organs. If I want to find what the size of a particular organ is, it's easy to automate the measurement. So that's one kind of problem where AI is really, really fast in doing it. The second thing is an augmentation. So things that a doctor might miss. So can you highlight? A typical example is in CT and MRI, there are a lot of sequences and series. Think of this like multiple images that are stitched together. So if a particular CT has 250 images, which of the image has a problem is really, really hard to know. But if you can really point out that, 47th image has a problem, could be a problem, doctor, can you go and then check, is much faster use of everyone's time. So that's an example of where augmentation comes in. This can be achieved in two broad areas. One is in the field of computer vision. So whatever we as humans that we can see, can we train the models to can we train the computers to make decisions based on computers? Or the second way is, can we use natural language processing to either understand what's written in the text or help in generation? A lot of this talk today would be focused on the NLP, natural language side. That's also the rage right now with large language models, LLMs. And so the focus of today's talk would specifically be on how we could use LLMs, and how specifically we use LLMs to drive a lot of value for our ecosystem. It could be doctors, it could be for patients. To start with, at a very high level, think about an image that comes, a CT brain that comes, has multiple slices. It comes in a format called DICOM. DICOM, very, very simple, naive way of explaining it. It is just a JPEG with some JPEG 2000 format with some metadata attached to it. In addition to it, you need to know the history of the patient. So there's some reason for which the patient has come. So the patient might have had a fall, might have been unfortunately hit in a road traffic accident. It could just be age-related stuff, that they're having headache, but could be something where there's a history that needs to know, because that definitely influences where the doctor is going to see, and age and gender. So that's important for the doctor to know. And with the images, the output that a radiologist generates would be a report like this, to know what's right, what's not right, and typically it's structured into findings and then impressions, the diagnosis of what the doctor looks into the particular report. Now that we have the context, let's go build a data product, right? Let's build an AI-driven application for the specific problem. This is the problem that we will work through over the next few minutes. think about this, that hospitals get lots of patients. They keep coming in, they treat the patients. So always a lot of data that's there. Some of it is structured because when you go, you fill out these forms. So you have your name, age, gender. Some of these structured information exist, but a significant proportion of it are unstructured. So there's like some medication that's administered. There's some inference that the doctor writes in a paper slip. There's all these reports and images and blood tests that are done. So all those data exist in a database, but not necessarily in a structured format. It's a combination of both structured and unstructured data. Consider a case where a patient comes in with showing some symptoms. And let's say that the senior experts are not available. A typical example is like, say, night 2 a.m. It's an emergency ER is where a lot of these patients come. There's an emergency case that's come. Just based on the symptoms, can the duty doctors understand what was the past treatment? Can you have some insights so that you would have some understanding of possible treatment options? Doctors know, but can we augment them with some insights that can help them save lives? Here's a more pictorial representation of that. There's a lot of data in the particular hospital. Eventually, we want to do data analysis of the patient, so we need to understand from historical data what's around, and then the doctor should be able to query and interface with the particular data itself to get relevant insights that's needed so that they can use it to either treat or understand possible treatment options. So that's the concept. So let's spend the next 5 minutes understanding some of the basics of what large language models are. We truly live in the golden age of NLP, where there's like tremendous explosion of work, of interest and work and output that's come in the field of using human language and then using that to drive a lot of value for business and for general, for all of us, for humans. LLMs are at its core, they just trained deep learning models. What they do is they understand and generate text in how we talk and interact in human-like manner. The way it happens is it take a lot of corpus of data that's available on the internet, and then it's trained, and these models are built, and these are available on or as public APIs. The most common one is ChatGPT. A lot of us would be aware of it. So that's a product by OpenAI. So here's an example of querying on the console of ChatGPT of what large language models are. So it has got a query. It's just like a chat interface. This is a question that we ask, and then it generates an answer, right? So it's very different from, say, the current search engine models work. This is generative AI at work. So you have a question, and based on the question, the answer is generated. Now, which means that these are trained models that are already deployed on cloud, which means that we need to find a way to interface with these models, which means that the ability to ask the right questions is super important and critical. This field of asking the right questions, posing the questions to get the answers from these large language models, called prompt engineering. So what specifically prompt engineering is, it's the art and science of communicating with large language models. The way you have to frame the question in a way to achieve the desired outcomes. But also this is just querying the large language model. So we're not really going and retraining the models. So there's no retraining of the models, there's no updation of weights. All that's happening is that we are just querying the LLMs. Two dominant ways in which you can query. One is called ZeroShot, the other is called FewShot. What those things are, let's look into it. ZeroShot is we just ask directly ask the LLMs what the question is. For example, I had dinner at the small cafe last night. Your coffee was fantastic. Now tell me what the sentiment of this is, right? This is like literally a question that you would ask the console, and it would come with an answer that's out here. It's got some implication. If your question is extremely generic, straightforward, then ZeroShot works. But almost always in practice, it's very rare that we would use ZeroShot. The most common thing that we would use is FuseShot. In FuseShot, what we do is we provide a number of demonstrations. We provide an input and output of the desired task. And then, so we think of this like we bias and we give inputs telling this is what we are expecting to the LLMs. And then we ask the question on our target task and then expect the LLMs to respond. So here is an example. So we start with telling that this is like this is how sentiment classification is done. This is awesome. It's a text, and then it's positive sentiment. So we give the pair of input and output that we are input and expected output. And then once this context is provided, we are asking for giving an example for classifying these sentiments for some sentences. This would work. This would summarize, generate, and give that the response would be this is extremely useful as a positive sentiment, while the other one is a negative sentiment. So far, we saw this in terms of the console, but console, as you know, is just interactive. It's good to know, but as engineers, as developers here, we can do better. The goal is to go use this, to code this, and then put it in an application. And that's what we're going to see over the next many slides on how we can go and do it. At a very simple level, this is how the code looks like. There is a library from OpenAI called OpenAI. So if you go to OpenAI and sign up, you'll get an API key. That's the API key that you're setting up here, and that's it. This is the prompt that you're telling what's happening here. So we are actually providing it as a FuseShot, and then the last thing is what a horrible show, and then we want to know what the output is. So that's the typical approach. Now we'll do a couple. Now we'll start building on top of it. So this is like we have OpenAI. We are giving some prompts and we have some answers that come out of it. But to build LLMs, it's not like one question that we're going to give and then get it back. We need to have a lot more structure and framework in place. Specifically, it's not just one question that I'm going to ask. It's a series of questions that I need to ask. Right from ingesting my data, asking some questions, and then asking more questions. So we need a framework that can chain them together. So the most important libraries that have come out in the very recent past is something called Langchain. Langchain is a framework that's built specifically for large language models. It's got both a Python API and a JavaScript interface. What it does is that it chains together the different components, and we can orchestrate it for a simple use case to build extremely complex use cases. It's got a number of interesting features, templates, index, and agents. So we'll see a little bit more on what these things are. It's super simple to install Langchain. It's just pip install Langchain. And the way to use Langchain would be something like this. We start with the template. We give what's the question, and it gives an answer. Now, what's a prompt template? So when we start giving, we want to experiment with different prompts that's happening, right? We want a template that has, so we want to provide some templatizing to the prompts that we provide. So for example, if you see this is a template that's, I want you to act as a radiologist, and then what's the most common finding found in RT, right? So this is, now I can start replacing finding with specific example. So I can replace it with hemorrhage. I can start finding with specific hemorrhage, for example, subdural hemorrhage that's out there. So we can start adding instances, or in fact, that's found there. So different things that we see can be put there as we iterate over this particular template. So it helps us do that. It parameterizes the entire prompt. The next thing is the interesting. So there are a couple more interesting things. Is index. We have many documents, right? So there's a bunch of documents that we want to query and understand. A document is, so for example, in our case, it'll be every report is a document. So there's a patient who goes, gets done an MRI, that's one report. And then say 1,000 patients go and then get done their MRI. So there are 1,000 reports that exist. Across all of it, we need to query and then get some answer, which means that they need to be indexed in certain way. So Langchain automatically provides API interface for indexing these documents, so that when we do the retrieval, which is take the user's query and then return answers from the specific document, it's super easy and simple. The third important use case is use of agents, right? So sometimes we want to interface APIs with external stuff. For example, we want to interface with Google Maps API or some other calculator, right? When these things need to happen, agents is a feature within Langchain that helps us take actions for specific applications. So three things that are super important that helps you create, so you can think of some way in which you can create these templates that can go through multiple multiple options, while agents let you work in some automated way and interface with the external world as well. This is all good in terms of, so Langchain provides a framework for orchestrating the prompts and the LLMs. But one common challenge exists because we're still relying on a third-party API like OpenAI to give it, and that is generative in nature. And one of the challenge in generative nature is that every time you call, the output may not be in the same way. It could be following different ways in which the output comes, and that becomes a big challenge. So we need the output and some structured format, because this is going to feed into some downstream application to run some stuff. The most commonly used one is guardrails. Guardrails is a Python package that allows you to add structure, type, and quality guarantees for what the LLMs give as output. There is a rail that you define what the rails for your application are, and then your guard, when it interfaces with the API, it ensures that it doesn't come out of the rails. So that's typically how guardrails work. Now here, the rail spec is the most important one here, and it follows some kind of XML structure where you tell that, okay, this is gender, it tells what the description is, so it's got the different things that's over here. So this is the spec. And then in your guard, you're just going to ensure when you call it, you need to ensure that it follows that particular paradigm. The rails are followed in while executing. Here is a sample output. So we've given OpenAI for the same thing. We have all this information that comes, and then the output comes with, we need all the abnormality center. So it extracts these information and then gives these information. This is obviously a sample data, but this is something that comes, right? Okay, so we've seen Langchain to orchestrate LLMs. We have seen guardrails that helps us put these guardrails in place to ensure that the output is in some structured format. Eventually, we need to store this output in a database for further processing. The two common ways: you can go store it in some database, SQLite, Postgres. the other thing is to go now, this entire concept of a vector store, we can go and then store in vector store, or common thing, if your data is not really too huge, you could also use your memory to do that. And for this particular example, I'm just going to store it in a pandas data frame. Data comes and then it stores in a pandas data frame, and that's good enough for what we do. Healthcare, the most commonly asked question is that privacy is super important. Healthcare data requires, in a lot of countries, you have extremely heavy compliance in place where the data cannot leave either the premise or the country. The data center has to be there. If you're going to use something like ChatGPT, which is based on OpenAI, and it's trained on public data residing in a remote server, most probably not in your country, how do you ensure that privacy is taken care of? So this is super important. And also, a lot of times the data is sensitive and you don't want to leave the premises of your virtual private cloud or your company premises. One common framework that's commonly used here is Llama Index. It's very similar to Langchain, but here it allows so two components it solves, right? So it helps you solve ingestion and indexing. Similar to Langchain in a number of aspects, but the big difference is it helps you augment with your own private data. So it helps you create these indices that you can then query. So you can take a pre-trained model and then you can augment it with your own private data. For example, you have these 10,000 patients reports. So you take a public model and then you update the models with your own data, and then the data and the model resides on your own server. It doesn't leave your server, so you can just use this to iterate and then build models specifically for your use case. The API structure is extremely straightforward. This is like, so you have, for example, you could just use a pandas index from Llama. So you're telling for this particular data frame, give me the pandas index, and then it creates it. And then now I can ask a question, which is the city with the highest population. It now knows that these are the ones that are mapped. It's stored as a pandas index, and it will be able to return what the answer is. A slightly more non-trivial example of some of the stuff that we would use is we have a report that's entirely come, and then doctor has a query. They would go and then write something like previous, like I want to know the number of patients who had intraparenchymal hemorrhage. So that's like severe hemorrhage and it needs to be immediately acted upon. If not treated on time, the patient probably dies. Need to be something that needs to be acted. It's very time sensitive, and so we want to know how much has come, and then gives the result. So we can use that add or trained on custom data that we have using Llama Index, and then return, and then it tells that for each of the days what percentage of it came with intraparenchymal hemorrhage. So that's how it works. Now we talked a bit about Langchain that helps us interface with ChatGPT. We talked about guardrails that specifically tells that these are the various fields that I need to extract, and this is the structure in which I want. And then once we have this, we can also train on our own data. The final part of the puzzle is putting these together into one simple app, ideally just all using Python, that then the end user, for example, a doctor or a physician or a radiologist can immediately interface with and get. There are three simple ways in which one can build apps in Python. I'm discounting building really complex apps using HTML, JavaScript, and backend frameworks like Django and Flask, but something where there are ready-made components and can immediately start building. Three major ones: Streamlit, Gradio, and Pinecone. Pinecone actually compiles into Next.js. It's upcoming, probably a lot more powerful, but the most common one is Streamlit, and that's something that we use quite a lot. Streamlit has these out-of-the-box components, and a lot of these visualization libraries work with absolutely no change as a fully functional app. So this is how it happens. You import Streamlit as into your library, and then you draw, and then all you tell is in Streamlit there's an altered chart, there's the spec of the altered chart, and then you tell there is some container width, and that's it. So here's an example of how that would even look. So there's an answer, so enter the question, the doctor enters the question, and then here's the answer. So we saw that in a notebook interface 2 slides back on how this would look like. On an app, this is how it would look like, where there's a text box where you can enter, and then once you enter, the output comes as a chart. Recap how this looks. There are multiple reports. We need to extract and then interface and then ask some analytics questions. The way it will work is use Langchain, use few-shot prompting, so prompt engineering there with few-shot examples. Use guardrails to specifically extract the metadata and features that you need. Store it in some DB. For us, the Pandas data framework's really fine. And then if you want to train or deploy it in specific hospitals where it needs to be trained, updated on custom data, you just use Llama Index. The query happens and the result comes. The query itself could be done using an app like Streamlit. That's pretty much the end of the talk. Thanks, everyone. Happy to take questions.
Thanks, Bargava, for your session on that. We do have our question box open, so if anyone has any questions, they can log them into the Q&A below. But if there aren't any questions, then I think that we can wrap up this session. Of course, Bargava, thank you so much for sharing your knowledge and showing us just how transformational and how dynamic Python can actually be, and the role that it plays in the way that it impacts lives. Thank you so much for being a part of PyCon 2023. And we'll see you all soon in the next session. Thank you again, Bargava.
Yeah, thanks. Thanks, everyone. Bye.